Nuclear fusion. What is it? It is not nuclear fission, it is quite the opposite in fact. It is the combining of two or more lighter nuclei producing one heavier atom, and also energy is released in this process, lots of it. Why is this important? Nuclear fusion has the potential to produce huge amounts of energy without any nuclear waste byproduct that fission produces. Hydrogen fusion of tritium and deuterium, heavy isotopes of hydrogen with more protons, produces only helium and the neutron. Also, the hydrogen is readily available, making the entire process very eco-friendly. Fusion reactors are much safer as there cannot be any nuclear meltdown that releases radioactive isotopes into the environment. It is a greener, safer energy for the future. Just why does the hydrogen fusion release energy? Atoms have a thing called binding energy. This term is slightly misleading. What it actually means is the energy released in the binding of the subatomic particles when the atom is formed. The binding energy of helium is greater than that of the combined binding energies of tritium and deuterium, so the energy input required to break the subatomic particles in these atoms is less than the energy released when helium is formed, so there is a net energy output. The problem: the reaction yields 17.6 megaelectronvolts of energy. However, it requires an approximate temperature of 40 million Kelvin, that's just over 40 million degrees Celsius, and pressures of around 250 million atmospheres. Not feasible. The solution. One solution is a tokamak reactor. The fusion must occur in a plasma, but the plasma cannot touch its container or it will lose heat and the fusion will stop, so it is suspended in a magnetic field. Net power can be described by the Lawson criteria. As high temperatures and pressures are required to produce the plasma and suspending it in the magnetic field, and all this uses lots of energy, current reactors cannot produce enough net energy profit, so fingers crossed for the future that one day we may achieve sustainable nuclear fusion, as it could be the only final solution to our current energy crisis.